Today, we are going to pull back the curtain on machine learning, and I'm going to let you in on a little secret. There's really just one simple, kind of counterintuitive idea that's the engine behind all of it. If you can get this one thing, you'll basically understand how every AI, deep down, really works.
So let's just jump right in with a puzzle. What if I told you that the smartest AI, the one that aces its test with a perfect score, is actually the dumbest one in the room? I know, that sounds completely backwards, right? But stick with me, and by the end of this, it's going to make perfect sense.
So to figure out that puzzle, we have to uncover AI's biggest, most surprising secret. It's this fundamental truth that once you see it, it just changes how you look at every single algorithm out there. And here it is, here's the secret. Forget all the crazy jargon. When you boil it all down, almost every single machine learning model is just trying to do one of two things. It's either trying to predict a value, like what the price of a stock will be tomorrow, or it's trying to classify something, like, is this email spam or not? That is it. That's the entire game. Okay, so let's zoom in on that first one, prediction. We're going to use a really simple case study to see exactly how an AI learns, and more importantly, how a supposedly perfect AI can completely and utterly fool us. Let's just imagine a kind of silly scenario. We get a group of people together, and we measure just two things about them: how much yam they eat and how fast they can run a 100-meter dash. Our entire goal here is to build a model that can predict a person's running speed just by knowing how much yam they ate. Simple as that. Now, this first batch of data we've collected, it's got a special name. We call it our training data. And you should really think of it like the only textbook our little AI is allowed to study from. Every single thing it's going to know about yams and running has to come from these specific examples. Okay, so now let's build two different AI models using that same training data. You can think of it like a showdown between two different ways of learning. And one of them is about to make what I like to call the perfect mistake.
So on one side, we've got Model A. It's just a simple, humble, straight line. Yeah, it's not perfect, but you can see it captures the general idea, right? The more yams you eat, the faster you run. But then, on the other side, you've got Model B. This thing is an overachiever. It's this complex, squiggly line that's a total perfectionist. It literally twists and turns to hit every single data point. It doesn't miss a single one.
So, looking at this, and based only on that textbook we gave them, which model looks smarter to you? I mean, which one looks like it actually learned the lesson perfectly?
Almost everybody points to the squiggle. I mean, of course, right? On paper, it looks like an absolute genius. It got a perfect score on the data it studied, it has 0 errors, it has absolutely memorized its textbook. But that brings us to the most important question of all. Did it memorize the book, or did it actually learn the lesson? And this, right here, is where the entire game changes. Because the real goal of machine learning isn't just to get a perfect score on the practice problems from the textbook. The real goal is to see how the model does out in the real world. So it's time to put our AIs to the test.
And to do that, we need a totally fresh set of data, something called testing data. These are brand new runners that our models have never, ever seen before. This isn't the practice quiz anymore. Oh no, this is the final exam. And believe me, it is the only grade that actually matters.
All right, let's grab one of our new runners from the testing data. First, the simple line makes its prediction. Okay. Then, the genius squiggle makes its own prediction, which is way different. Now, we compare both of those guesses to the runner's actual speed and see who is closer to reality.
So after we do this for all the new runners, here are the final scores. And just look at that. The simple, humble line, it had a really small error. It was actually a fantastic predictor. But the complex squiggle, the one we thought was a genius, it was a total disaster. Its predictions were just all over the map. So what happened? Well, it didn't learn the actual trend, it just memorized all the random little quirks and noise in the original data. There's actually a name for this. It's called overfitting.
And this whole experiment perfectly illustrates the single most important lesson in all of machine learning. Seriously, if you remember nothing else from this entire explainer, please remember this. This is the golden rule of AI. And here's the rule. It does not matter how fancy or complex an AI is. It doesn't matter if it got a perfect score on its training data. The only thing that matters is how well it performs on new, unseen testing data. That is it. That is the true measure of a smart AI. And you know what? This golden rule applies to everything, not just our YAM example. Let's say you build a model that tries to predict if someone will like a TV show. You could build the most complicated decision tree in the world using your training data.
but the only way you'll know if it's any good is to test it on a brand new audience. The best model is always the one with the best score on the unseen test data.
Period.
So, now you're in on the secret. The next time you see some big headline about a breakthrough AI with 99% accuracy, you'll know the single most important question you need to ask. Okay, but is that 99% on the training data it already memorized, or is that on new, unseen testing data? Trust me, that one question changes everything.